Have you have you ever thought about you've touched upon something here with your ability to move around. Have you ever thought about the fact of what it was like in a proprietary environment for writing software? Like, say, maybe you were a database expert working at Oracle or a compiler expert working at IBM. When you went to HP from IBM, in operating systems, for example, because those proprietary platforms were so different, even though you were, an outstanding star in that particular technology, be it compilers, operating systems, whatever. When you change companies, you started from the bottom because you don't have that 20 years of legacy knowledge as to why they did all those things that they did. Usually, you actually don't have mailing lists that you can go back to and see why they made those decisions back when they did, right? And so you're starting as a newbie, whereas one of the freedoms that I've always found really interesting and compelling for developers in open source is as an expert in an area of open source, you can freely move companies and you're just as good at Kubernetes at any other place as you were at Google. And that kind of freedom allows you, and that reputation gives you tremendous mobility as a developer. I mean, have you ever pondered that and versus the way it used to be for developers in proprietary world?
Yeah, I mean, when I used to work at Google the first time, we had these proprietary systems for provisioning servers and doing the burn-in process. Google would get pallets of servers at a time, and they would go through this burn-in process where you would net boot the machines, and we had this specialized image that would go in and burn out and stress test the memory, CPU, disk controllers, the whole nine. And I just thought that's how everyone did things. And I was like, oh, this is just how you do data center. And so when I went to Pier One, no, right? You people got firewalls hanging out the back of the rack from an Ethernet cable because there's nowhere to fit it in the rack. People are just gluing together Perl scripts to make things work. And, maybe there's not a lot as much system design, but it turns out a lot of that system design at Google from the machine database that registered all the hardware components. You could scan the MAC address from the outside of the server and then tune what role it should play. Even the top of rack switches were customized. And so you have all these conveniences and you go somewhere else, you're just like, what are we doing? Why is this process taking so long? Where's all that stuff at? But fast forward like almost 15 years later, when I came back to Google in a whole different capacity. And in that mode, I remember years later, Ors, wrote this very famous maybe book or paper called The Network is the Computer, or The Computer is the Network, or The Data Center is the Computer. There it is. And he just talked about like when you think about a big distributed system, these data centers themselves, in many ways, become the computer. And so, in order for Google to pull this off, you got to build every layer hardware, network, everything. And so, when you do that, though, you have a huge advantage, especially during that time in the early days of search. But boy, oh boy, something happened. That Docker thing was arguably better than the container thing Google was using. That Terraform thing was arguably better user experience than some of the Borg config people were trying to use. And I remember him publishing this thing internally where Google has to get off their own digital island. When Google goes into the cloud business, we have to interact with the whole world. So that means having a faster YouTube or search using any means necessary, custom hardware, custom networking protocols, you can do that. You only have to integrate at the edge. And even then, they made their own browser to really accelerate what they wanted to do. But what happens when a customer wants to run their workloads in your environment? Well, things change. Now you have to start leveraging virtualization. Now you have to look at the tools that they actually use. And once we started to do that, people started to realize, like, wow, this Envoy thing, this new network proxy, it has some things we don't have. It's extendable. There's a community behind it. And every time we get on our own digital island, we get stuck there. So a lot of people are like, oh, why did Google not release Borg as open source? Because you wouldn't want it. It is so intertwined to the way Google's been working for decades. There's probably some legacy things in there. And if it's not legacy, it's unnecessary complexity that won't match your real world. You want something like Kubernetes instead, which has been designed from experience of that world, but adopting some of the best of breed things like etcd, Docker, the way we think about cloud computing in modern times. That's what you get from Kubernetes. And so I think even Google kind of struggled with this. Being on your own digital island could actually put you behind if you stay there too long. So now I think with the world of open source, you're watching all of this innovation occur. No matter how big or how small you are, if you're paying attention, you realize at some point that your homegrown solution may be no match when the whole world agrees on something and decides to move forward together without you. Now you're just behind.
You mentioned Kubernetes a couple of times. Were you part of the forming of the project and community, or did you join later?
Yeah, so I was not at Google at this time. I was at CoreOS. So Google for a couple of years had been working on something, right? They saw Docker and all of these other things, Brendan Burns, Joe Beta, Vile, Craig McLuckie. These are all the people at Google deciding that there should be something they can do here. A lot of people don't realize that when I was at Puppet, around the time Go was being created, Google released a container project called Let Me Contain That For You, written in C++. I looked at it for all of 7 seconds and decided that this is probably not going to be working for me or probably anyone else. And it really didn't go anywhere. I would imagine around that same time, because that's how the timelines work out, that they were probably working on something like Kubernetes, probably had a whole different name, right? We like to use code names and stuff like that internally. And so I'm at CoreOS and we have the operating system. And our tagline was like Google's infrastructure for everyone else. So we would read all the white papers, and it turns out there were a lot of new techniques for doing a lot of the things that Google will talk about in the Borg paper, right? So instead of a tool called Chubby, we had etcd. Instead of that OS, that kernel stuff that Google used to do, we had CoreOS. And then when we wanted to work on a scheduler, we had this tool called Fleet. And so Fleet used System D to schedule jobs that would then run containers. So Docker plus System D equals Fleet backed by etcd. Then you can actually have this consensus and do all the things. And then we get an email from Google like, hey, we're about to announce an open source project. And I don't even know if they told us it was Kubernetes, but I remember the night before we got access to an embargoed press release. I mean, you can't talk about it until they release it. And I got access to GitHub. And so we're like, hey, we're doing our own thing. We don't even know what this is because there's no guarantee just because it comes from Google it's going to be successful. So I get to the GitHub and I'm just going through the project like, hey, look, I think Red Hat and others are going to be a part of this announcement. They're going to be talking about it at DockerCon. CoreOS ain't in the mix. So I got access to the repository and I was like, look, they're going to put out a press release about what it is. Maybe we can show them how to use it. And so I'm building the binaries. Maybe there's a few bugs. You're patching things. And then I'm like, this got to work on CoreOS. So I'm running it on CoreOS. You're doing everything you can to make it work. And then you write instructions. And I remember the day Google announced it, hey, Kubernetes, blah, blah, blah. And then we were like, hey, CoreOS, the thing they're mentioning, you can run it. Hey, come to our site. And there was this page we had. I did the whole thing on VMware Fusion. And so you just stood up some VMs on your laptop, copied some binaries via SSH, and you had the whole thing running. And you could experience this idea of running containers using Kubernetes. So that was kind of my first entrance into the space. But then there were missing parts to Kube. Like networking stack was like not well defined. It piggybacked on Docker. So one of the first contributions, me and this guy named Eugene, I mean, he's super deep on the networking side, and we did the CNI. And I remember one of the first design decisions we made was the API. He's like, Kelsey, what should the API be? And I was like, well, Docker did this rigid API where you have to do networking the Docker way. And if you've ever done networking before, that ain't going to work. I said we should have no API. We should slide the entire network namespace to whatever wants to configure networking. And its only thing is it must give us an IP back. So what that does is allow you to, if you're Juniper, you can use your elaborate stack you want. Provision L3, routes, upstream, BGP, doesn't matter. Do what you got to do to make this IP routable. Just give us back the IP. And so the first implementation was a disk-based IP management, where I would just create a container name per file, and we put your IP in there. And so when you started the container, open the file, wrote it in there, you close the container, we deleted the file. And that's how we managed it so it will scale from one node to multiple nodes. And so CNI became the foundation for Kubernetes and lots of other projects. And I did all these little things around what does it mean to be a node, how it registers itself. There was some refactoring. The project was written by a lot of Java people. So the Go code base looked like Java. So we used to call it Guava. Like this is a combination of Go and Java. And so I did a lot of those contributions. But this is when I think I found my speaking voice because the work comes first. For those listening to this, it's not always about speaking at a keynote because what are you talking about? The work comes first. So you do all these open source contributions. And if you said nothing, then no one would know. If you didn't write any docs for those contributions, then no one would know how to use them. They'll just be in the code base doing absolutely nothing. It's only when you get on stage, and I remember at the time, you would contribute, build something, ship something, and then you would go on stage. Hey, there's this new thing called Kubernetes. Here's how it works. Well, does it do this thing? No. Next presentation. Now it does this thing. Here's how that works. And so it's that feedback loop because you got to know what to build. And you can't know what to build until you really start to examine how it fits in the real world. So those are a lot of my contributions, the code, the talks, the auxiliary tools, and then the book. And it just reminds me of how I started in open source. You find a problem, you fix it. You fix it, you share it. You share it, you explain it.
So kind of completing the circle of the learning, doing, and teaching.
This is a humanity thing. I think a lot of people believe this is some specialized tech thing. And this is where I think people get lost when we start to get into the philosophical needs from open source. Humans create style and culture and words and recipes, and we share with each other so other people can experience these things. We like that. We take pictures to show people. We put on fashion and colors so people can see it. And this is a thing that may inspire someone to also start wearing yellow hats. It's a thing we do already. It's just that when you apply the same spirit to open source, ideas now can spread much faster. Like one of my favorite phrases of all time, some people have ideas and some ideas have people. And the way you get to the lather is that you literally have to share. And so when you take that same human philosophy and you move it into tech, you end up with this thing we call open source. And when people forget that, then they over index on what license are you using and not think about the governance model to see if you would even accept any contributions under that licensing model. And that's the thing that I think completes the full circle, what we call open source.